Hey guys, Mo back with another repair. This one hopefully should be pretty quick. Well, at least I hope, as I'm starting to take it apart now. This is a Twister Audio half-bridge amplifier. It looks like a 1500 watt RMS at 1 ohms, mono block class D. It looks like the client, I guess, what he stated is he had it mounted, and the feet that he had the amp mounted with seemed to have broken off as they were plastic. And as the amp got loose, it looks like his wire shorted out. And you can see there's some pretty good burn marks in regards to basically melting the plastic of where the ground connection was. There's a better view. So I just initially did kind of a polarity check to kind of see if things are shorted. It doesn't. It looks kind of everything's open at the moment. So I went ahead and started taking it apart before I started recording, but I figured, hey, why not go ahead and do another video in case this helps someone out, or if it's consistent with some of the other Twister amplifier models. So I did start taking it apart. I'm gonna go ahead and flip it upside down here real quick. There we go. And I haven't gotten a chance to take measurements yet, but I figured that when I did a visual right as I took it off, I can see that there was some damage here where the ground connection was, and it looks like even the tracing down below is damaged. So what I've seen, usually, again, this could be various things, but the number one thing when I see something like this is you probably have a very bad ground connection. And most people are deceived by thinking, no, you know, I screwed it into my chassis, it's great. And I've seen some of these installs and I look and it's mounted directly to a painted area. It wasn't scraped off, or the paint protective coating on the actual chassis wasn't removed. So you're not getting a really good ground connection. So it's a very high resistance point, even if you have good cable. And that probably reflects into what happened here. And also if he didn't have this ground connection really tight in here as well. Again, it's because it's so low voltage at 12 volts, 12 to 14 volts, it's very, very high current. So you really need to have a good electrical connection at your grounds and power. So that's what I'm guessing here. High resistance point, heated up pretty bad, heated up the solder below. But I don't see anything else messed up. I went ahead and took all the heat sinks off of the MOSFETs, both for the input stage and the output stage. I don't see any burn marks anywhere else. So I said, hey, you know what, if this is damage that has to be fixed anyways, well, I got to take it apart. But before I do that, I'm going to go ahead and do some MOSFET checks. As you remember, when you look at these MOSFETs, gate, drain, source, gate, drain, source. So what I will do is check between the gate and the source, as well as the gate and the drain, which is in the middle. And what that's telling me is, these are N channel MOSFETs, NPN, which means they're usually always open until you apply a signal to the gate. And when you apply an electrical signal to the gate, then they close the switch. So naturally, when you don't have any load or anything on it or any power, they should always be open. If a FET is damaged, usually you'll see a short. And that's why I like to measure gate to source as a preliminary check, to kind of see if FETs are damaged or not. And they should easily be consistent across all the rest, with the exception of the rectifiers in the middle. So that being said, I'll go ahead and do a quick multimeter check across all of the FETs and see what we have. But I know for sure I'm going to go ahead and take it apart. So maybe I'll just go ahead and take the board apart first out of the chassis, since I'm going to have to do this repair. And then I can check all the FETs and see if I have to replace any of them. Again, this is a Twister Audio. It looks like the M1500.1 half-bridge amplifier, half-bridge topology, Class D. Pretty good looking components in here. Looks like pretty beefy, so I would expect that it does fully rated power. They got a combination of both discrete and, I'm sorry, not discrete. I thought I saw some surface mounted components, which is abundant. But yeah, well, actually pretty good components. I don't see a lot of leaded parts other than just the diodes, and that's normal. So good deal. Let me go ahead and pull it out and see what we find. Okay, guys, before I take it off, just hopefully this helps anyone that's going to take it apart here. So there's only one screw that holds the board down to the actual chassis. And that screw is located in between the input power terminals as well as the output speaker terminals, and it's right here. So that is just the only screw, and it makes the good electrical ground connection of the board to the chassis. Other than that, the board's actually held by the heatsink caps that screw these FETs into the side of the wall of the chassis itself. So once you unscrew these right here, and there's a whole bunch of them. So we got 1, 2, 3, 4, 5, 6, and we turn this around. 7, 8, 9, 10, 11, 12 of these are used to hold all the FETs and diodes themselves. So once you get these removed, put them in a nice secure little area so you don't lose them, save all the screws. Then this should slide out relatively easy. So I'm going to go ahead, rotate this here, and you should be able just to kind of slide one end. Now I can't get this particular cap off because of the damaged, burnt up portion of this plastic housing here for the ground. So unfortunately I can't get it off like I did on the other side, which this pops off. And you can see the culprit was the fact that this plastic cap had the mounting feet on there and it broke off and it caused damage. So it's just bad design. Hopefully there's some revision updates into Twister Audio's newer models, which I'm not very familiar with, but I know I've seen them around. But hopefully that they improved mounting feet, especially in a harsh environment like a vehicle where it gets really hot, really cold all the time. So that being said, I should be able to go ahead and slide this board out of the chassis, and I will need both hands here. And it looks like it is coming off. Oh yeah, before I forget, you want to be able to also take just a simple dental tool. This is my Harbor Freight Special right here, Pittsburgh. Without putting a lot of force, you should be able just to kind of get it between each FET and just kind of break the contact that they have currently against the side of the wall. This helps loosen it, so when you're trying to pull it out, there's not a lot of tension. As you can see, I didn't really have to do a lot. You just barely move them this way, and that way it breaks the seal. And what I'll do when I go back and install this, I'll probably put more thermal medium to help being able to transfer the heat from the MOSFETs over to the heatsink. All right, so I need both hands. Let me jump off, pull the boards out, and board out, and see what it looks like. Okay guys, so I got it out, and as I said, that one screw just helps kind of mount the board over to the chassis and makes that board to a chassis connection. So that being said, I'm going to get this out of the way, but just wanted to kind of show a close up here. So instead of making direct contact to the heatsink, there is a piece of Kapton that electrically isolates all of the FETs and diodes from the chassis. But there's a whole bunch of thermal grease, and what that does is help transfer the heat from the devices over to the heatsink itself, and that is going to be on both sides. But very simple, very straightforward, so I like this design in the sense of the chassis and the board. What is terrible is these plastic things. That's just someone slept on it, or at least cut cost in regards to this bracket to hold everything in place, and still I couldn't even get the entire plate off. It's still stuck on this terminal, and so I have to see what I can do. So let's get this out of the way at the moment. Let's get the heatsink out of the way. Let's look at the board. So the board overall, again, looks like it's in good shape. I don't see visually any damage on the board. I don't see any residue of any marking. Again, what I see is you don't have a good ground connection. So I'm guessing the reason that there's no power or anything or isolation, it's probably just the ground connection soldered itself off and everything is actually just fine. But what I'll do, I'll go ahead and make this repair first, since it has to be done anyways. Let's look at the back of the board here. All right. Be careful as you're handling it. Usually I would use two hands. But again, I don't see anything wrong with this board other than just flux, which is normal on all these cards. It's not conformally coded or anything, but it looks like there was just a lot of heat applied to the ground connection at this point, and that just basically bubbled up the solder and the loose connections came up. So try to repair that real quick. It should be straightforward. And then we'll see if we're able to kind of power it on. Well, obviously, before I do, I'll check the FETs. But I'm confident the FETs should be fine. All right, so let's go ahead and look at it. Okay, guys, so got the board, checked out all the FETs. The FETs are fine, as I suspected. And what I'm seeing here is, as I zoom in a little bit on here, you'll see that there is no ground connection whatsoever from this ground post. Now, unfortunately, I can't just bend it back to make a good ground connection, because it's pretty much tied in with the other leads here. So when I say tied in, it's the same plastic housing. This plastic housing that holds all three pieces together, which is the power, remote, and ground. And so when I try to force the metal back to be able to solder it, what I'm noticing is it's also trying to bend the plastic and the metal for the other posts in there. So it's putting a lot of pressure. So what I am going to do is I am going to take my Dremel, and I'm going to do it the right way. I am going to remove the plastic around the ground section and isolate it. That way I can get the lead soldered properly. And what I will do is go back and isolate it properly, so that way when it is ready to be reused or reinstalled, we don't have to worry about the ground shorting out to the metal piece or anything next to it. So let's go ahead and get going and see what it looks like once I do it. All right, guys, so here's some progress made. So what I did is take my Dremel wheel. This is my carbon cutting wheel here. There you go, you see it. I love these. I use them for everything around the house and various repairs and just homework. So that being said, I took that wheel and I tried carefully isolating the ground encapsulant plastic from the power and remote. So that's still intact. And what I was able to do now is, if you look carefully, I can now move the ground without putting a lot of tension or force on these leads. And that's going to allow me to kind of go back and push this down properly and get it soldered. So if you see now, I have a lot more play that I can push this down, get that soldered properly, get that secured, and I'll go back and I'll find a plastic encapsulant where I'll go ahead and ensure that it is completely isolated and make it look look good. So overall, I think this is coming along. Again, we said the FETs were fine, but obviously if you don't have a ground connection, the amp's not going to turn on, and hence why we weren't seeing any response. So let's go ahead and see if we can make this solder repair. It looks like just like 4 pins that go into the hole. 4 holes. So what I will do is just reflow it from the bottom, loosen that up, and then go ahead and push this down and secure it with additional solder, high temperature solder. So let's see what it looks like. All right, so as I got the plastic cleaned up, this came right on off. Here is your ground terminal. So very similar to your power, and as you can see, solid metal. Let's see if it's magnetic. No, just the screw is magnetic, so it must be an aluminum block that is machined, which is nice. So it does need some high temperature solder to be able to put this on. And as you can see, 4 legs that are used to help mount it to the board. And here you go. As we zoom in on this, you see the 4 points that the legs would mount in, and you can see the complete isolation between this block. So what I am not fond of is this plastic. I've never seen this plastic melt so easily, which is kind of disappointing, because this is a very high current draw. So when you're talking about 1500 watts RMS, that's over 150 amps DC that you're pulling from the amplifier. That's a lot of current, and it's going to heat it up. I don't care if you've got 4 gauge or even 1/0 down with a coupler to 4 gauge. This plastic is going to get warm just because this block is going to get warm. So that being said, I'm kind of disappointed in this plastic. Definitely a manufacturing flaw in this amplifier. I'm not sure if Twister, who they are owned by, or if they're affiliated with another company that makes other product, but kind of disappointed. Very cheap plastic, comes apart very, very easily here. In fact, it's already breaking in my hand, so there's no doubt that obviously this plastic was the reason this amp it wasn't secured. It caused the wires to short, and now that I'm trying to solder, it's just falling apart. So pretty cheap, pretty disappointing. I'm hoping that again it was just an isolated manufacturing flaw with this specific amplifier, not the whole line, and definitely not all of their other products. So let me go ahead. I'm going to remove the solder from here, get a nice clean solder area ready to go so I can mount this, and then I'll get ready maybe to isolate it before with some Kapton. That way when I do encapsulate it with some plastic and form it, it'll look really, really nice and maintain its isolation. So here are the 4 holes. They've been cleaned out of solder. That way it'll be a lot easier for me to go ahead and place this right in a hole, which I would do like this. And let's see if I can do it with one hand. And it's going to be hard to do with one hand. But I will be able to kind of go ahead. Oh, I'm sorry. Not even looking at it. I will be able to go ahead and get it on there once I get the feet all cleaned up. Press it down, secure it, make the solder connection. And like I said, I'll probably wrap this around in Kapton and just ensure that it's completely isolated from anything else. That way when we put the brackets back together, it still maintains isolation. You still got the full functionality for connection, and you're good to go there. So let's keep going. Okay, guys, just before I go ahead and put it back in place, I went ahead, after I placed some Kapton on here, I went ahead and put some electrical tape around it, more for visuals. Obviously, the Kapton does a pretty good job of isolating, and it's only 12 volts, so it's not a big deal. Got the legs all cleaned up, got the holes all cleaned up. Got this entire section moved for where the ground would be. So once I put it in here, right, and secure it, visually it should be decent. And then I'm going to reinforce it with some dark epoxy where it really blends in and still fully functional. So pretty much ready to go. Like I said, I'll apply some heat to it, get the solder going, make sure it's a really nice, good ground connection. I want to secure this in case there's any further tension on with the wires or it pulling to the left or right. Obviously, we lost the mounting legs, and what I'll do is just add some heavy-duty industrial grade Velcro on the bottom. That way, when someone does want to mount it securely, they've got a really good method to be able to secure it either to a box, to their interior upholstery, or anything else. So, but overall, this will look good. Obviously, it's unfortunate this plastic is coming apart. I don't want to go ahead and remove all of the other terminals. I have a couple other amplifiers lying around, but they use slightly different configurations, and it's just not worth hacking into it, as this is a decent repair here. So let me get it mounted. Let me see what it looks like, and then we'll show you guys. Okay, guys, so I was able to go ahead and make some good progress on this. Went ahead and did my initial support stage, I guess you can say. In this particular case, I used a very robust sealant. This is the Permatex RTV. This is almost military grade, guys. So very strong, very high temperature resistant, very durable, but still very pliable. But this is perfect kind of for this case to be able to support this without having to use epoxy just yet. So by doing this, I went ahead and reinforced the main terminal after I soldered it, and went ahead and put the RTV all around. And the RTV, the important place to have it is not just only on the terminal itself, but make sure that as it dries off, it helps bond to the everything around it. So that includes those back caps and the entire terminal block that's remaining, as well as the back of the board and the bottom of the board. And I went ahead and put some right below it here to help, again, with any tension and minimize any stress that would be placed on that terminal. So I still have some more to put it in, but I will fine tune all of the little gaps here and a little bit more on the edge once I put it in the enclosure, or the chassis, excuse me. Other than that, I think it came out pretty good. I did do a quick test, and it powers up just fine, which is great. I don't like to keep them on without a heat sink just because of the power dissipation on these FETs, and there's no way for the heat to go. So that being said, let me go ahead and start putting it in a chassis. As I mentioned, I've got some a thermal medium that I'll go ahead and put behind each of the FETs. As you can see, there's the thermal grease residue on here, not a lot, which means that, you know, they didn't put a lot on there. So I will go ahead and put some of the very high thermal conductive adhesive that I have, or medium should I say, to help be able to push that heat out from the MOSFETs over to the heat block or the heat sink. All right, so let's keep going. Okay, guys, so got the boards mounted, and there's that one screw that's going to hold the board to the chassis. And before I proceed, I just wanted to show kind of the thermal medium that I use. This is superconducting thermal medium, thermal compound. Here's the model number if you guys are interested in using it. Very robust. I really like this brain from Zalman, and it works great. So what I do is I don't put a whole lot. So you can see it's just a little dab behind each FET, and when I push that back with those heatsink blocks, it's gonna kind of smear it and spread it out. So I did that all around for all the FETs that we have here. That way we can reinforce it with some additional thermal medium and help pull that heat out. And a cool amplifier is a very reliable amplifier. So I'm going to go ahead and now mount the heat sinks. I call these the heat sink blocks, I guess. And that's going to put the pressure on each of every 2 MOSFETs or 2 diodes. Get those screwed in, and then we can go ahead and start powering it on, make sure it's fully functional, and then look at how we're going to close up the box and make it look good. Here it is, guys. So I got it all put back in the chassis. Got all of the heatsink blocks installed. I think we counted 12 earlier, so got all those done after I put the adhesive. So you can see on both sides. So that looks good. And then I went ahead and reinforced it a little bit more back in this area with additional RTV. Again, I really hate these plastic terminals. In fact, I'm just not comfortable with how they're going to hold everything on. So I went ahead in every corner, I added a little bit more RTV. This helps with any vibration that could allow it to come loose and gives it a little bit more stability. And so I did add those in every corner here, just so the plastic can hold on to the edges there. So where the chassis, the plastic, and the board, as well as this metal piece, holds in place. Here's what it looks like from the front. Excuse this, as I was ready to power it on here in a second. So doesn't look too shabby. Again, I've got some more touching up to do in regards to just making it look a little bit better, but completely isolated, very sturdy, which is great. Got all the screws put in, so that's fine. I think the final thing now is just to kind of go ahead and put on that back plate. But that being said, I went ahead and connected these wires with a dummy load, just so we can go ahead and power it on, and then ensure that it is working. So got the positive here and got my ground. All right, now I need to go ahead and connect my RCAs. Let's see here. There we go. All right, so I think on this side is where I'm going to have, excuse the mess here, my indicators for the LED. So let's get that going. Oh, connection came loose. Sorry about that. Let's try it again. There we go. All right, and my subwoofer's humming. I see the blue LED, so we got power. It'd be nice if I got some music going. And unfortunately, I'm gonna have to change my setting. That way, whatever I play, YouTube does not block or put a big ol' ad on it. So let's see what. Okay, so it's working, which is nice, and that's what I want to see. There's no protect. Again, I got a good ground connection here to the board. I've got the block secured. Again, we'll make it look nice and neat. Probably do one last clip here and connect the right wiring to it. That way we can run some real power through it. But overall, simple repair. It's unfortunate that that took place, but again, it's still usable. We'll give it back to the client and see if he wants to use it or sell it, whatever he wants to do, but a fully functional amplifier again, and go from there. So hopefully I don't see a lot of these come back in the sense of having the same issue, because then that would say it's more than just an isolated incident. Obviously, a lot of amps use plastic, so it's not about the plastic, but it's just the quality and where it's leveraged, I think, is very, very important. All right, thanks, guys. Let me put it all back together, and we'll do a final clip. Here's the final product, guys. Got it all put together. Got it all buttoned up. Got it all connected to some good wiring here. So let's go over what we did. So obviously now that's buttoned up, it's hard to see, but we came in and all of the support that was around the ground lug had been completely melted. and it looks like there was enough heat on the electrical joint and the metal joint that it came off the board, so you weren't really getting a good contact. So what we did is take it out, clean up all the burnt up or melted up plastic, made a good solder joint, and then reinforced it with additional insulation as well as the epoxy to hold it in place. So now it looks pretty good, as you can see, in a place. So we're obviously still a used amplifier, but a fully functional amplifier and all button up. I still am not a fan of all the plastic that was used. As you can see, kind of just broke off in different areas, but got it powered on. There we go at 12.2 volts. Here we go. We don't have any red buttons to show us that it's in protect or anything like that. So if I can flip it over carefully, there it is, all buttoned up, and we can look at it from this point of view here. And as you can see, got that looking like it should, or the best we can do at the moment. And unfortunately, the plastic is just completely broken off. So what I was thinking is I'm probably going to go get some ABS plastic that is black, the same size as the bottom, that extends out about an inch on each side, and make that the new plate. So that way it's got a new mounting plate. So when someone does want to use it, they can either use adhesive, or it can have 4 corners that they can mount this amplifier to. So I'll probably do that, just not anytime soon. So I'm just glad I got the repair done. Wanted to go ahead and connect it to you guys, for you guys, and run it. Good amplifier. It does its power, so there's no doubt about that. Good internal components. Just the finer details, right? That's the difference between things falling apart and breaking apart and not lasting, and then brands that do last. But overall, still a good amplifier. I've got it connected to my Infinity Kappa. This was the 120.1. One of my favorite sound quality subwoofers that I have, to be honest with you. I've got a whole line of Infinity Kappas throughout the years. They've just been great. Sound quality is great. They did come out with the new one. It's it's not the Kappa series. It's I guess the Reference or Primus series that looks like this, but it's yellow. Not the same thing. This is really interleaved glass, which is really nice. So very light, but very, very, very strong. Butyl rubber. This one in this particular model is, let's see. There it is. Kappa 120.9. So 350 RMS, 1400 peak. Again, very, very good sound quality subwoofer in the right box. Great for small sealed enclosures. Or if you want a little bit more SPL, which these aren't really known for, you can put it in a larger ported box, about 1.5 to 1.75. Sounds amazing. Great for all music genres. Maybe I'll do a video in the future with all the different Kappa subwoofers that I have, but definitely one of the better ones that I played with. So let me kind of secure this again, since this just snapped off, and we can get some music playing. I'm going to need both hands. Okay. So 1 second. All right, so I got it secured. There it is, running off of the Twister M1500.1D. I've got my current meter. So this current looks at the input current to the amplifier. Again, this is a power side to the amplifier, so that's 12 volts. So let's run some power. It's going to be just bass. And here she goes. Got this thing moving. Yeah, she can flex. For a single 12-inch, again, with really, really, really good sound quality, these subwoofers are just one of my favorites. So I refuse to sell these. I've got this. I've got the green Kappas. I've got the white Kappa Perfects. I've got the new black Infinity Kappas. Really good subwoofers. So let's see what kind of power we're running through here. About 17 amps on the input, right? You multiply that by 10 approximately, so you're getting about 170 watts free air movement. So again, this amp can do a whole lot more. I'm currently got, this is has the impedance selector, so you can do 2 ohm or 4 ohm. I've got it in 4 ohm at the moment. So again, not pulling any power from this. Very low heat, good amplifier. But again, another good repair. Anything can be fixed, guys, to a degree. Unfortunately, just little defects here and there will always exist, but there's always a solution one way or another. So hopefully you guys like this. I hope it helps someone out there to make a repair for their amplifiers. And if you like, please go ahead and hit that like button, hit the subscribe button, hit the share button. Really appreciate it. I look forward to making more videos. Thank you.